So now we shall explain the Bayes theorem. Bayes theorem. So if E1, E2, E3 till En, this are non-empty events. It means what? It means that Ei should not be equal to phi. For all I goes from 1, 2, 3 to n. It means no event should be a null set, uh, and which constitute a partition of the sample space S. Shoot a partition of the sample space S. It means what? It means that they should be pairwise disjoint. It means they should be pairwise disjoint. It means, as we have told already, that EI intersection EJ that should be equal to phi for all I comma j, for all I not equal to j, and I comma j should be 1, 2, 3 till n. And what? And they should be exhaustive also, and they are exhaustive events. Means it means that EI means E1 union E2 union E3 union till En, that should be equal to S. And suppose we also have A, which is an event. A is any event having non-zero probability. Having non-zero probability. It means what? It means that the event A should not be equal to phi. And it also means that the probability of the event A should not be 0. Then we can say that the probability of happening of the event EI, given that the event A has happened, that is equal to the probability of happening of the event EI into the probability of happening of the event A, given that the event EI has happened, divided by the total probability of the event A. It means the total probability of the event A, we can write it as the probability of the event EI into the probability of the event A, given that EI has happened, divided by the probability of the event A, that is summation of I goes from 1 to n, probability of, so we should write it j goes from 1 to n, so probability of EJ times probability of the event A, given that EJ has happened. So this is applicable for all I equals to 1, 2, 3 till n. So for any event EI, it is applicable. So here, one thing you should note that um, these events, which is E1, E2, E3 till En, which are the partition of the sample space, these are called the hypothesis. These are also called the hypothesis. And the probability of the event EI is called The priori probability is called the priori probability, priori probability of the hypothesis EI. It means these events are also called, each event is called as hypothesis. Hypothesis. So P of EI is called the priori probability of the hypothesis EI. Okay. And the conditional probability, the conditional probability, which is P of EI, given that A has happened, is called the posteriori probability. Is called the posteriori. Is called the posteriori probability. Posteriori probability of the hypothesis EI. Okay. So the Bayes theorem simply states this one. So we can understand this theorem by using a suitable example. So let's understand by using one example. Uh, so let us suppose we have three identical boxes. We have three identical boxes. Three identical boxes we are having. This is box 1, this is box 2, and this is box 3. Okay. Each containing two coins. Each contains two coins. In box 1, both coins are gold coins. In box 1, both coins are gold coins. And in box 2, both are silver coins. Both are silver coins. And in box 3, both are no, in box 3, one is gold coin. Suppose I shade the silver coins and the unshaded ones are gold coins, suppose. So here we have one silver coin, one silver and one gold coin. Okay. Then a person has to choose, a person has to choose a box at random. A person has to choose a box at random, and he has to take out one coin. He takes out a coin. So first he has to choose the box, then he has to choose the coin. Okay. First he has to choose box and then he has to choose the coin. Okay. Then if the coin is gold, so it is if it is given that the chosen coin is gold, if it is given that the chosen coin is gold, then what is the probability? We have to then what is the probability that the box also contains the only gold coins? That the box is containing only gold coins. So what is the probability that the box is containing only gold coins? That we have to find. So here, let us take, let E1, E2, and E3 are the events that the boxes 1, 2, or 3 are chosen respectively. It means I'm saying that the probability of choosing the box 1, that is E1, the probability of choosing the box 2, that is E2, the probability of choosing box 3, that is E3. So therefore, obviously, I will tell the probability of the event E1 that is equal to the probability of event E2 that is equal to the probability of event E3 that is equal to 1 by 3. Since there are 3 identical boxes and out of them, any one I have to choose. Then also let the event A be the event. Let A be the event, that is the coin drawn is gold. The coin drawn is a gold coin. Okay. So therefore, we have the probability of choosing a gold coin, given that we choose the box 1, that is obviously 2 by 2. Since there are 2 gold coins and out of that we have to choose 2, so it is 1. And similarly, the probability of choosing a gold coin, given that we choose the box 2, that will be obviously 0 by 2, which is 0. And the probability of choosing a gold coin, given that we choose the box 3, that is 1 by 2, since there is 1 gold coin out of those 2 coins. So now we need to find what is the probability that we choose the box 1. Since why? Box 1 is only containing all the gold coins. No, box 1 is only containing all gold coins. So what is the probability that box 1 is chosen, given that the the chosen coin is gold? So we have to find P of E1 given A. So here we have to use the Bayes theorem. So that will be the probability that the box 1 is chosen times the probability that gold coin is chosen from box E1 divided by the probability that we choose box 1 times probability that gold coin is chosen from box E1 plus the probability that box 2 is chosen times the probability that gold coin is chosen from box E2 plus the probability that box 3 is chosen times the probability that gold coin is chosen from box E3. Okay. So that will be equal to 1 by 3 into 1 divided by, this will be 1 by 3, sorry, 1 by 3 into 1 plus this will be, this is 1 by 3 into 0 plus this will be P of E3, that is 1 by 3 into this is 1 by 2. So the answer is 1 by 3 divided by 1 by 3 plus 1 by 6. So then we will get 1 by 3 divided by, this will be, this is obviously 2 by 6 I can write. So this is 3 by 6. So then we'll get 1 by 3 into 6 by 3. So that is 2, 3 are 6. So sorry, 3, 2 are 6, 3, 1 are 3. So the answer is 2 by 3. So 2 by 3 is the final answer. Thank you.